Morning everyone. So let's talk about our Monday's lesson, which is on area of composite shapes, right? So composite shapes, what are composite shapes? We have talked about 2D area, one-dimensional objects, two-dimensional, three-dimensional objects. With 2D objects, we can compose some shapes. Right? Let's compose some shapes. Let's say this is a rectangle. Right, and I'm going to add a triangle with it. I've added a triangle with it, right? That's a rectangle, that's a triangle, and I'm also going to add a square with it over here. I've gone a little bit further down. Let's say you've added another rectangle with it, right? So that rectangle, and that triangle together, it creates a shape, and this shape is going to look like like this. If I remove these middle lines, they're going to look like that. A sort of an R shape, roughly, not really R, right? This shape. So this shape doesn't have a name because it's composed of a few shapes, and therefore this is a composite shape because it's made up of some other basic shapes. You may also have a shape like this: a triangle, a rectangle, a parallelogram, and a square. Wow, hot shape. So that's a square, that's a parallelogram, parallelogram, so I'm just not going to fit the full thing over here, triangle, and that's a rectangle. So together, all these shapes put together next to each other, it has created a composite shape. Let's remove all these lines in between. It's going to look like this. Like that. So that's a composite shape, right? So that's a composite shape. That's also a composite shape. How are you going to find the area of a composite shape? It's very simple. You simply find the area of the individual shape and just put them together, add them up. In this also, you're going to find the area of the triangle, rectangle, square, and parallelogram, and just going to add them up, right? Let's start with one of the questions that's been given in your Monday's lesson, today's lesson, okay? So bear with me. Okay, so just continuing to our first worked example. Oh, all right, mic. So I'm just continuing with the first worked example for Monday's lesson, 26th of July, 2020. That's the worked example that's been given in your pack, in your raffle pack for Monday. So that's a composite shape, and you are required to find the area of this composite shape. How are you going to do that? First of all, you need to find out how many shapes is this composite shape made of. So this composite shape is made of a rectangle. So I'm just going to highlight that rectangle. So that's the rectangle. Its length is 25 centimeters and width is 20 centimeters. And the top part is a semicircle or a half circle. Semicircle means half circle, right? So you need to find out the area of half circle and the rectangle. So how are you going to find out the actual area? The area that we are after can be written as the half circle area plus rectangles area. These two, if you add them together, you're gonna get your actual area that's required in the question. So let's proceed with that. Which part is easier for you? Obviously, finding the rectangle's area is easier. So rectangle's area is length times width. So this bit is length times width. Length is 25. So I'm just going to substitute the value into the formula. That's the formula for area of rectangle. So I've just replaced this by this. And length can be substituted as 25 times width is 20. So I'm just substituting values into the pronumerals or these symbols, right? So length symbol. Okay, let's multiply them, and when you multiply these two together, you get 500 centimeters squared. Okay, because your dimensions are given into centimeter, that means your area is going to be centimeter squared, not meter squared, and you cannot leave it empty either. You must use your unit of measurement. Unit of measurement is really important. 500 tiny squares of centimeter size. Centimeter size square, if you want to know which one are those, the one that are given in your maths book. You know how your maths book is grid? Each of those box is a centimeter square box, and 500 of those can fit onto this rectangle. That's how big this rectangle is. So you can imagine fitting 500 of those squares from your book into this shape over here. That's how big the shape is in reality, right? In actual bit. Okay, now let's do the harder bit, which is half of a circle. So what if I find a full circle and then half it? So divide by 2. Yeah, so full circle divided by 2 is going to give you half circle, or full circle's area over 2. You can write it as a fraction as well. And what's full circle's area? How do you find the area of a full circle? Is by using its formula and then halving it. So what's the area of circle? So can I just use this space to show you the area of a circle? I hope I make a convincing circle. Yeah, that's a circle. That's the center of a circle, and the distance from the center to the edge, you need to know that. No matter whether you want to find the circumference of the circle or area of the circle, if you want to study about circles, you must know the radius. And what is radius? Radius is the length from the center to the edge. So this distance or this gap or this length is called your radius. Okay, from here to here, that's also a radius, that's also a radius, that's also a radius. So all these are radii of this circle, so they go in all directions. So the measurement is pretty easy. You got to use your head over here, how you can apply that over here. So full circle's area divided by 2. Now full circle's area formula is area of a circle is, it looks like OA, but this is a circle, so I'm just gonna, so circle's area is pi. Now pi is a constant, it's a irrational number. For convenience, we have taken pi's value as 3.14. So at the moment, you remember that pi's value is 3.14. Every time you use a pi, that means we are actually asking you to use 3.14 in place of pi. There will be another video on just pi. Where does pi come from? What are the special characteristics? Everything about pi in another video. So let's just stick to pi right now here. So area of a circle is pi times radius times radius. It can also be written as area of a circle is pi r squared, because r squared means r times r and times pi. So pi times r is the formula for circle's area. So we're going to just use that formula, substitute the values in it and calculate that. So pi is 3.14 I've substituted, times r is how much? Okay, how do we know the r? So our circle is this much, that's our semicircle. How do we find the radius? Okay, I need to draw this again so that we can actually figure out the radius. Okay, maybe it's given in the question, but you still need to know how to find the radius of circle in certain conditions. So that's your half circle, right? Okay, and this length is actually 25 as well. If this is 25, because it's a rectangle, this is 25, this is also 25. So that means this bit is 25, okay? And that's actually the diameter of a circle. That's the width of a circle, because if the circle was full, that would have been the whole diameter. So therefore, radius is half of it. So radius is just half of this diameter. That means your radius is actually, okay, that means radius is actually half of 25, because this entire thing is 25. So that's 25, that's 25, but radius is only this much. So that's radius. Okay, and that's half of 25. So I'm going to half 25 over here, which is going to give me 12.5. Okay, half of 25. So in a fraction, when you write half, that's how you write it. So that's the radius, just substitute it over here. So pi is 3.14, radius is 12.5. Again, radius is 12.5. We are going to times all these using a calculator, and we're going to get an answer. Let me quickly do it on the calculator. Okay, 490.6. So that's going to give you 490.6. I hope it's the bottom bit is visible. So 490.6 centimeters square, that's the area of full circle. Now remember, that's the area of full circle. Okay, so this is area is 490.6. So you have to half it now, because you only need half of this circle's area. That's this half just. Okay, so this half circle, right? So let's do that. So full circle's area is 490.6, and you're going to half it, and then you are going to add it. So add with 500 centimeters square. Okay, you don't have to add it right now, just half it first. Now this is 490 and decimal 6. How do you half it? Half of 400 is 200. Half of 90 is 45, because half of 80 is 40 and half of 10 is 5, so 45. Decimal 6's half will be decimal 3. So we have halved it successfully. So this, we have solved this. So that's the half plus 500. Now how are you going to add this? Now there are quite a few skills involved in this question. That's a pretty good question in that sense, because it's testing your area substitution, remembering the area formula. It's also testing your substitution, if you can substitute values. It's also testing you the multiplication. It's testing you if you can identify the radius of a circle, area of composite shapes, of course, and it's testing you how to half, and finally it's testing you how to add a decimal number with a non-decimal number. How do you do that? So these are the whole numbers. So 445 wholes and 500 wholes you're going to add. So 500 is complete quantity, and so is 245. So you're going to add those two wholes first and then decimals later, or decimals later. Let's stick to one way of doing it. So this is 547. So that's 745. And there's nothing here, so that decimal is 0 and that's decimal 3. So just going to add decimal 3, and that's your final answer, square centimeter. So area of this composite shape you have found out to be 745.3 centimeters square. And that's it.